All right. This is going to be me grinding. That's kind of, it's been no useful stream. Well, anyways. All right, so today's, we're going to try to do chapter 3 and maybe chapter 4 on alkanes and, I guess, cycloalkanes. All right, so why this chapter? The group of organic compounds called alkanes are simple and relatively unreactive, but nevertheless provide a useful vehicle for introducing some important general ideas. In this chapter, we'll use alkanes to introduce the basic approach to naming organic compounds and then to take an initial look at some of the three-dimensional aspects of molecules, a topic of particular importance in understanding biological organic chemistry. There are more than 195 million known organic compounds. Each of these compounds has its own physical properties, such as melting point and boiling point, and each has its own chemical reactivity. Chemists have learned through years of experience that organic compounds can be classified into families according to their structural features, and that members of a given family can have similar chemical behavior. Instead of 195 million compounds with random reactivity, there are a few dozen families of organic compounds whose chemistry is reasonably predictable. We'll study the chemistry of specific families throughout much of this book, beginning in this chapter with a look at the simplest family, the alkanes. So it's funny because they don't actually define alkanes until later in the chapter, but that's fine. 3.1, functional groups. The structural features that make it possible to classify compounds into families are called functional groups. A functional group is a group of atoms within a molecule that has characteristic chemical behavior. Chemically, a given functional group behaves in nearly the same way in every molecule it's a part of. For example, compare ethylene, a plant hormone that causes fruit to ripen. One thing is, it's very strange that ethylene is in plants. I don't know. It seems odd, but and menthene, a much more complicated molecule found in peppermint oil. Both substances contain a CC bond, double bond functional group, and both therefore react with bromine gas in the same way to give a product in which a bromine atom has added to each of the double bond carbons. This example is typical. The chemistry of every organic molecule, regardless of its size and complexity, is determined by the functional groups it contains. All right, so we have ethylene, and it breaks the double bond and then adds bromines to there. And so similarly here we have this like double bond. There's a methyl here. There's a whatever. Look at table 3.1, which lists many of the common functional groups and gives simple examples of their occurrence. Some functional groups have only CC double bonds or triple bonds. Others have halogen atoms, so I forget. Yeah, it's group 17. I don't remember the names of all of the... Let's see, if I go to P table, does it have it at the top? Alkaline, post-transition, non-reactive, no, but it doesn't have the group names. Oh, here it does. Halogens. But here it doesn't have group names. I mean, I guess the four that are really probably the most important are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. Those are kind of the four that I want to remember. Some functional groups have others have halogen atoms, and still others contain oxygen, nitrogen, or sulfur. So halogens, oxygen, nitrogen, and sulfur. Much of the chemistry we'll be studying is the chemistry of these functional groups. Functional groups with carbon-carbon multiple bonds. Alkenes, alkynes, and arenes all contain carbon-carbon multiple bonds. Alkenes have a double, alkynes have a triple, and arenes have an alternating double and single in a ring. They look different, but because of their structural similarities, they have chemical similarities. I really like these plots, by the way. These plots are really cool. These space filling plots. All right, so alkene. I'm going to actually draw all these out. I'm going to basically recreate this table, just go through it slowly, because at some point I need to remember these. Now, this is the alkene suffix "ene." Then we have the alkyne, "-ine." Then we have arene. So this is no suffix. Okay, then we have C to X. Oh, wait. Where X equals F Cl Bri. Fickle brine. Fickle brine. This is called a halide. So like chloromethane. We gotta memorize these. So, okay. Alcohol, this one's easy. Alcohol, all. So the suffix. Okay, this one, these start to get into the ones that I don't know. COC. It's kind of this. Apparently, it doesn't specifically have to be C, but it has to be it has to be organic or something. Organol. Okay, fine. So this is called an ether, and its suffix is ether. So let's do an example for this one. So an example is dimethyl ether. So we're gonna have H3COCH3. Dimethyl ether. And if we look that up, is that really the... I mean, we'll get into nomenclature in a bit, but I'm just curious. They always have the IUPAC. Bro, UPAC is... In any case, okay, monophosphate. So we're gonna have like a C to a O to a P O O O, and then two of them have one negative formal charge, so they got 3 lone pairs on them. And then one's a double bond. Suffix diphosphate. And diphosphate is going to be like C O P O P O double bond O, double bond O, O, and O. So then there's only, then there's a, this example is methyl diphosphate, which is 3 minus. So CH3 OP2O6 3 minus. Okay. That one's pretty easy. All right, here we go. Amine is interesting because it doesn't have to be. Oh, it does have to be. Okay. Maybe I'm thinking of amide. Oh, well, here you go. Primary, secondary, and tertiary amines. Oh, interesting. Okay. All right, so amine. Yeah, so suffix amine. Example, methylamine. Which, if you're a fan of Breaking Bad, they talk about methylamine all the time. So it's fun to see it show up. And it's such a simple molecule. Just C3NH2. Okay, an imine. Schiff base. So if we look up and here we get R1 R2, but it's really about the C double bond N thing. Okay. No suffix. Okay. 11. Nitrile. Nitrile is a CN triple. You hear nitrile occasionally. Okay, there's ethane nitrile, which would be CH3C C triple one N. Yeah. But there's probably also this, so this is ethane nitrile. We probably have HCl N. It's going to be methane nitrile. Well, what is the definition of cyanide? So the nitriles are also called cyanides. I wonder if that's because they have a cyan color. It's probably not. Oh wait, it is. But cyan, what is cyan? Yeah, it's a blue-green. Okay. So it is. That's interesting. You learn something new every day. Okay, so those are also called cyanides. 12. Thiols. Okay, so thiols are cool because sulfur behaves a lot like oxygen, I think. This is called a thiol. And its suffix is thiol. So methane thiol. Methane thiol, you'd have a C, S, H, 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 H. And then you should have 2 lone pairs on S, right? So then it's going to have a tetrahedral structure. And then C is going to be tetrahedral as well. So let's try to draw this out. So, we have a C. It's so hard to draw these tetrahedrons. Let's draw an H here. H and the wedge. Damn, I messed it up. Okay, how do I draw the tetrahedral? Okay, that's what I'm gonna do. So it's gonna be like C, wedge, and then kind of right H, H, and straight up H, and then we're gonna have an S, who's gonna have 2 lone pairs coming out like this. So it's kind of bent, right? Because it's gonna form a tetrahedral structure too. So if we look up on PubChem, methane thiol. Yeah, so it's bent. And they show sulfur's big. Yeah, that makes sense. All right, so that's cool. And then I think I'm going to look up a Quizlet or something. All right, here we go. We got a sulfide. So it's sulfide. C, S, C. This is really, R1, S, R2. It's kind of like the ether of sulfur. And the suffix is sulfide. So the simplest sulfide has to be like dimethyl sulfide or something. Oh, there you go. Yeah. Because like ethers and sulfides need two organyl groups. So if we look up dimethyl sulfide, yeah, they call it thioether, but didn't I thought there was already a thioether. They also sometimes called thioether. I definitely prefer the name thioether. What's the origin of the thio for sulfur? It's just Greek. What the hell? Interesting. An archaic name for sulfur. All right. All right, so we got the sulfide. Now disulfide. Now I think they're putting disulfide in here because I'm pretty sure disulfide is really important in like amino acids. But why don't we have a diether? Like, why can't we have? So this would be R1, S, S, R2. So we could still have dimethyl, or yeah, dimethyl disulfide. Dimethyl disulfide. Yeah, exactly. But so can't we have dimethyl diether? No. But can't we have? The dimethyl peroxide then? Okay, so but for R O O R prime is not dimethyl diether. This goes to peroxide. That's interesting. Okay. 15 is sulfoxide, which is, RS plus RO minus. And the suffix sulfoxide. I'm gonna go put on some shorts. It's warm. My life, my life, my life. My life, my life, my life in the sunshine. All right, so sulfoxide. Yeah, so what's the simplest sulfoxide? Dimethyl sulfoxide. Let's look that up. Dimethyl sulfoxide. Oh, that's interesting. It is an important polar aprotic solvent. Aprotic solvents are solvents that lack acidic protons. That's cool. Dude, I actually love this stuff. I'm gonna freaking love OChem. This is gonna be so interesting. Because all this stuff, like, chemistry was industrialized, like, well, it depends on how you look at it, but way before biology in a industrial sort of sense. I mean, you could talk about agriculture and stuff like that, but in the way that I'm thinking about it, like, these processes, it's crazy. Wood into wood pulp. I just watched that movie about the what is it? No Other Choice. The paper thing, and I just love the. Oh, that movie. I actually rated it too low. I should probably change my letterbox because that movie actually kind of rules. Which consists of almost pure cellulose, the main component of paper. The craft process involves treatment of wood chips with a hot mixture of sodium hydroxide, sodium sulfide that breaks lignin. Oh, interesting. No way, the craft paper. That's so funny, bro. That's the number file paper. That's funny, man. Craft paper roll. But so they don't bleach it after? Oh, my life, my life, my life. Dun 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 dun. Dun. The common paper mill pipeline. Chip, debark and chip, make pulp, separate fibers from lignin. Wash, screen, pulp, remove spent chemicals, knots, dirt, optional bleach. Chlorine dioxide. What is that? That's just. Wait, what is chlorine dioxide? Oh, wait, oh, whoa. Because, yeah, because chlorine is a. What do they call the rows of a periodic table? Okay, period 4. So they're a period 3. Huh. See, that's the fun thing about this stuff is like you go down these rabbit holes and you see all this interesting stuff. Like I was never gonna expect to learn something about how paper is made. So what happens exactly? So dimethyl sulfide is made as a byproduct of paper making. Okay, that's how we got here. All right. Okay, now we get to some of the important ones because I mean, sulfoxide is probably important, but these are the ones that you hear about all the time. So the aldehydes. So an aldehyde is like R, C double bond O, H specifically. So it has the, and then its suffix al or all. Okay, so what would be the simplest methyl, methyl, methyl? I don't know. Do you add the suffix or do you replace the ol with the al? Because if we did ch, actually no, there's even a simpler one where you just have ch2. You just have HCH double bond O. What is that called? So this is probably called, so that's called ethanol. So we have methane. Then we take the E, methanol. So if we look up methanol, so this is actually called, methanol is actually called formaldehyde. But then we can also get ethanol, which is CCHOHH. All right. Okay, that's cool. So those are the aldehydes. All right, so those are the aldehydes. You know, mixed mode learning. I'm gonna write some of these on the board. Okay. So those are good. I guess I forgot about thiol. Yeah, thiol. 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 You can remember thiol like in like oxygen, like an alcohol, but with sulfur. So there's some logic here if you like dig in a little deeper. Thiol, all. Okay, what's next? The ketone. So ketone's actually kind of new. Ketone doesn't really relate to much else. So we have R, C, R prime, C double bond O. Dude, all of a sudden there's like a 500 little bugs here flying around. Where did these bugs come from? All right, anyways, so we get the ketones. So the simplest ketone would probably be dimethylone. Oh, they call it propanone. Yeah, I guess that makes sense. They call it propanone. But we could probably have it be. But see, that's the thing is you can actually make it ethanol too. So this is where you get some overlap, I think, because you can. But you can make propanone, which is CCCO and then HHH. Okay. Propanone. Carboxylic acid. This one's really common. This one at this point I know by heart. The suffix is oic acid. And it's RCO double bond the O to 1 and then an H on the other one. And so the simplest would be probably methanoic acid. Yeah, so there's probably a special name for methanoic acid though. Yeah, they call it formic acid. Yeah. Hmm. So then let's look at ethanoic acid. Oh, interesting. Okay, so then, all right. Dude, I am loving this. So then, ethanoic acid, which is, let's say, CHHH, C, double bond O, single bond O, H. This is also called acetic acid. That's very interesting. All right, cool. So we did the carboxylic acid. All right, let's do the ester. All right, so what are we on, 19 now? Ester. Suffix 08. And the pattern R, C, double bond O, single bond O. Oh, interesting. So this is kind of like a mix between... No, this is interesting. It's a lot like a a lot like a carboxylic acid. So okay, so wait. We can't have... So if you put an H here, and then you put an... I mean, this is an R, but if you did H, C, O, O... See, that's interesting, right? Methyl ethanoate. But you could also do... This is probably called methyl... Wait, so... Wait, no. CH3CO. This one is called methyl ethanoate. The esters are weird. I don't know about the esters. All right, well, let's at least look up methyl ethanoate. I can't select this? I guess this gets rendered somehow else. Methyl ethanoate. Because acetate was... Yeah, so this is kind of the acetate. Yeah, the ordering of the R groups is interesting because it's like, in this case, they decided that the methyl, which is the like kind of right pattern variable R prime is the prefix. So I would guess that C C O O C C, H H H H H. This should be called ethyl ethanoate. So if we do ethyl ethanoate, would also be called ethyl acetate. Yeah. Used in the decaffeination process of tea and coffee. You know, it's like all these molecules that we found uses for them. It's so cool. All right, so we got the esters. All right, let's do the thioesters. So the suffix thioate, that makes sense. And then let's guess what the pattern is. If the pattern for the, I would guess that just the oxygens are replaced by sulfurs. Oh, it's only one of them though. That's kind of interesting. Okay, so the simplest one is if we replace the first thing with a H. But I think that there's a special rule that R groups can't typically just be H's. But what would that look like? I don't even know what you call that. I would just call it simply thioate. Hold on. Formic acid was also called methanoic acid. This is HC double bond OOH. This is methanoic acid. So instead, if you called it so that one's weird. But yeah, you would call it methane thio. Yeah, exactly. You would call it thioic acid. Methane thioic acid. So you could also call this methane thioic acid. But usually called thioformic acid. Let's look it up. Thioformic acid. It's probably used in something cool. Yeah, so kind of similarly we get, thiocarboxylic acids. Oh, we have some resonance here or something? Oh, tautomers. I haven't learned that yet. I don't know what that's about. Wait, really? Holy cow, dude. Yo, I'm feeling good right now. This is so cool. You read crazy stuff like thioformic acid is a chemical compound with the molecular form CH2OS as the simplest thiocarboxylic acid. It has been the subject of studies on its properties which may be extrapolated to more complex thiocarboxylic acids. Okay, blah, blah, blah. Thioformic acid has been detected in the interstellar medium near the giant molecular cloud. It's like, dude, that's crazy. I mean, also that there's organic compounds just floating around in space, like, that kind of blows my mind. Okay, good. All right, so the thioesters, though, we didn't really do the thioesters. So I guess the simplest one would be called, if we go from above. So we did the methane thioic acid, but that's more of a carboxylic acid type of thing. But then if we do, let's see, RC double bond O, or let's make this H, S, and then let's make this methyl. So this is CHHH. So this is going to be called methyl. This is going to be called methyl thioate. I bet. Methyl thioate. No, that's not it. I know what methane thiol is. Well, wait, hold on. Methane thiol. A thiol is like an all. Yeah, okay, that makes sense. But that's not what I'm looking for. In esters, we have the O8. And so we had the methyl ethanoate. Oh, so we need the methanthioate. Methyl methanthioate or something. So yeah, so this is methyl methanthioate, also called methyl formate. I hope I don't have to remember too many of these short ones. Uses. Is the methyl ester? Wait, this isn't right. Methyl formate is not what I'm talking about. Methyl thioformate. Methyl methane thioate. All right, so we got the pubchem for it. So we have. So this is kind of the way that I was looking at it. How can I rotate this? Damn it. I'm going to flip it like this. like this. Okay, so we have the... That's the way I drew it. So what do they call it? Methanthioic acid. So they're using the thioic acid form. So this is also called methanthioic acid. Because in a thioic acid, so the thioic acid, or the, what do we call them? Thiocarboxylic acid. The thiocarboxylic acids are going to be R, C, double bond O, S, H. So yeah, so if you, and then with an thioic acid suffix. So then we can just call it methyl thioic acid. That's probably the better name for this. Methyl thioic acid. Or methane or methyl? Methyl. Methyl thioic acid. Oh, wait. No. No, it's not. It's methane thioic. Methane thioic acid. But that doesn't really... No, that's ridiculous. That's not right. This doesn't make any sense. What is the alkyl group? What is that? In thioesters, the alkyl group is attached to S, so writing S-methyl methane thioate is extra explicit. Well, I'm gonna... Because, all right, let's try to get to the bottom of this, because I'm thinking... Okay, let's just start off with... If I have H, C, double bond O, S, H. I'm going to call this... So first off, we can recognize that this is the simplest thiocarboxylic acid. This is the simplest thiocarboxylic acid. Now, what do we call it? We should call it, if we called it with oxygens, we called it methanoic acid. Analog is methanoic acid. So then this should be called methanthioic acid. Now, I expect that to be pretty non-controversial. So if we look at methanthioic acid, I bet PubChem will have it. Methanethioic. This is different. I expect it to be called methanthioic acid. This top one is right. This is what I would consider methanthioic acid. That's fucking weird. Okay, I don't really get that. But honestly, it's above what I need to know right now, I think. Okay, so wait, so let's go back to the thioesters. So the simplest thioester is going to be dimethanthioate or something. Oh no, you name them separately. So the thioester, you call it methyl. With this first one is the methyl ethane. And look, they actually said ethane thioate. So there's some weird thing about the naming and how when you drop it, when you don't drop it. There's something weird going on there. I don't know what it is. But anyways, so for thioesters, we'll get if we get CCOS CH3 H. This is going to be called methyl ethane thioate. All right, so that one's kind of weird. All right, here we go. We're gonna get into some of the nitrogen one. We did the amine. The amine's kind of weird because you can. Yeah, actually, I should put some of those and nitrogen ones up on the board, because oh yeah, like the nitrile one. All right, let's do amides. So apparently amides are really important. I don't really get amides yet. So 21 amides. And the suffix is amide. And the pattern is, we have a C, or let's make it an R. We have an R. Oh, interesting. Okay. C, double bond O, N, lone pair, and then two things like this. So the simplest one would be H, C, double bond O, N, H, H. So this should be called methanamide. Methanamide. Yes, methanamide. Okay, and it's also called formamide. I don't know where all this formics, it's all historical. It's kind of like how meth, F, prop, and bute are like random, but pentex, etc. is like Greek. All right. Formamide is an amide derived from formic acid. So hold on. Let's figure out. Formic acid is methanoic acid. Oic is carboxylic, so methanoic is the simplest carboxylic acid. So it's HC double bond OOH. Okay. I'm starting to get it. Like, I actually am starting to get it. It's not that confusing once you draw about... Let's see, how many did I draw? Honestly, I only drew like 20 compounds. It's a colorless liquid which is miscible with water and has an ammonia-like odor. It is the chemical feedstock for the manufacture of sulfa drugs. And other pharmaceuticals, herbicides, and pesticides, and in the manufacture of hydrocyanic acid. Oh, here we go. Our old friend, the simplest nitrile. So, wait, hold on. But this really should be called methanitrile. Methan... Is it methanitrile? Or methane nitrile? All right, let's keep going, because there's like a whole 2 chapters to read about alkanes. All right, so we got the amides. The amides are like... The amides are kind of like the, not really like the thioesters, but more like the thiocarboxylic acids and the carboxylic acids. I mean, I don't know. Are there R groups here? Can an amide have R groups? Let's look up amide. Oh, yeah, okay. So actually, it is kind of like... So it's kind of like a thioester or an ester. Yeah, I would say the amides are the most closely related to the esters. So that's neat. Okay, acid chloride, oil chloride, ethanoyl chloride. All right, I've never heard of that one. So we get R, C, double bond O, Cl. That's the whole thing. This is the acid chloride. Oil chloride. Okay, so the simplest one should be called methanoil. So if we just do C, this should be called methanoil chloride. There's a lot of history from these names, especially the like informal names. But the systematic name is, wait, this is ethanoil. Yeah, acetic. No, but what I'm looking for is not that. I'm looking for methanoil. Formile. Bro, it's so funny, man. I love this shit. The Friedel-Crafts reaction. Are a set of reactions developed by these guys in 1887 to attach substituents to an aromatic ring. Friedel-Crafts reactions are of two main types, alkylation and acylation. Let's see, what do I say? Alkyne, so I say acylation. Alkylation, acylation. Okay. I'm driving myself crazy with these names, but it's important. Actually, I don't know if it's important, but it's fun. That's definitely what I'll say. It's very fun. So what is... And carbonyl. Carbonyl. Oh wait, is it called carbonyl? It's called there's carbonyl. Yeah, that's what I don't understand. What is the difference between carbonyl patterns and ketone patterns? Does this have a suffix? Because what is HC double bond H called? I feel like I already have that one. What is that called? Oh, that's the aldehyde. So that'd be called methanal. That's right. So aldehyde is like a half ketone. Yeah. So aldehydes are like half ketones. Okay. Okay. Man, they got names for so much of this stuff. All right, so we got the acid chloride. We got the last one here, 23. Carboxylic acid anhydride with the suffix oic anhydride. Okay, that all makes somewhat sense to me. Now let's look at the pattern. We got an R, C double bond O, C, C double bond O. Oh, no. This is an O. And then this is R prime. So if we just made it H's, what is this one called? This is called. That's weird. I wouldn't call it this. I don't know what I would call this. Because what if they're different? What if we have a H3C C O O C O H? Oh, acyl group. We got to get to the bottom of this acyl group thing. All right, so this first one is called methanoic. Ethanoic, methanoic, anhydride. So that's really interesting, man. Oh, these names are so funny. So all right, I'm gonna write that down because that's so weird. Ethanoic, methanoic, anhydride. So it's like anhydride. is a function that takes two arguments, but the arguments get prefixed. So it's like a prefix notation syntax. Or, yeah, that's really interesting. Well, I wonder. I mean, I guess as you're reading it, maybe that makes the most sense. Because if you said anhydride, I don't know. Anhydride, methane, methane. Because if you just, I don't know. I'm sure that IUPAC could be revamped, bro. I mean, I'm sure it's also pretty good, but I mean, when did IUPAC really come out? I mean, this is before any. Okay. All right. What do we got here? All right. So now we finally finished going through some of those. We can start reading about functional groups in more detail. Okay. Okay. Alkyl halides or haloalkanes. Alcohols, ethers. So Ether. Ether's like ROR prime, I think. Yeah. Alkyl phosphates, amines, thiols, sulfides, and disulfides all have a carbon atom singly bonded to an electronegative atom. Halogen, oxygen, nitrogen, or sulfur. Alkyl halides have a carbon to a ethers have two carbon atoms bonded to the same oxygen. Organophosphates have a carbon atom bonded to or oxygen of a phosphate group. Amines, nitrogen, thiols, sulfur, sulfides. Oh yeah, sulfides. Sulfides, I think, are also called thioethers. I'm pretty sure that's true. Yeah. Bonds are polar. The carbonyl group, C double bond O, is common to many of the families in Table 3.1. Carbonyl groups are present in a majority of organic compounds and in practically all biological molecules. These compounds therefore behave similarly in many respects, but differ depending on the identity of the other atoms bonded to the carbonyl group carbon. Aldehydes have at least one hydrogen. Ketones have two carbons. Carboxylic acids have an OH. Esters. Okay, wait, hold on. Ester. I think an ester has another R group connected to what would have been the proton, the acidic hydrogen in a carboxylic acid. Yeah. And then amides. Amides are like carboxylic acids too. Or no, amides are like esters. Amides are like esters. That's what it is. So acetone, what do you call that? It's an O and it's a ketone. So in my mind, because ketone has two patterns, I would call it methylone or something like that. But it's probably called like propanone. But I would call it methylone. Yeah, you could call it, yeah, I see, or propanone or 2-propanone. That's not so bad. Like that's fine. Man. All right, methionine. So we get an am. Identify the functional groups. This is called an amine. This is called a carboxylic acid. This is called a sulfide. Sulfide, otherwise called a thioether. Good. That one's easy. Okay, here, carboxylic acid. Arene. Did we do arene? I think we did arene. All right, here we go. We got arene. We got an ether. We got an alcohol. I don't know. I would consider this an amine. I would consider this a carbonyl. This is a carbonyl. You could also call it a ketone, though. That's the kind of interesting thing. Is like, if you look at capsaicin, how you name it is in a big molecule like this is interesting because like, you probably don't call it. Let's see. See, look at the. All right, so methylnon enamide. I don't know what enamide is, but see. Oh yeah, in a way that this is kind of like an amide. Yeah, you could think it because you have the C O double bond N, and then instead of using the second R group for something else, you're just using one of them, and it's this weird thing. Six EN 4-hydroxy 3-methoxyphenyl meth 4-hydroxy. This name is crazy. Oh my gosh. This okay, that I don't okay, I'm not gonna be able to name that. That is intense. And then here we got a Ian. Can we at least see Ian in the name? Is there an Ian in here? Three, four, five, six. 1, 2, 3, 5, 6. All right, so I don't even see the ene in here. I don't know where the heck the ene is. All right, let's just keep going because I'm not going to be able to name that. The name of that thing is insane. All right, proposed structures for simple molecules that contain the following functional groups. Okay, an alcohol. All right, let's just pick two. All right, let's pick amine and alcohol. All right, so we're gonna get a COH NH2 HH. Let's figure out what this is called. So here, because you kind of have, so you're gonna have methane, but you'd probably call it like, so methanol, but then methanolamine, methanolamine. So that's kind of what I want to know. It's like, how do we name if we have like H2COH? No, so you do, wait. That should be called methanolamine. That should not be called. Yeah, like this. Yeah, yeah. I mean, I don't know if. I guess there is like a difference between OH, NH2, HH. It's like this hydroxymethylamine, aminomethanol. See, I would call this. Let's see, what's the systematic name? Aminomethanol. But I would call it. Hmm. Yeah, that's interesting. I mean, I don't know. That's interesting. It's like, how do you turn a graph into a string? Let's make okay, aromatic ring. This one's easy. I mean, they're all easy. But let's combine it with something else. Let's make the simplest carboxylic acid. But an aromatic ring or an arene specifically has to have the alternating. So you kind of have to have. I'm pretty sure this is called benzoic acid. Wait, benzoic acid. Yep, that is definitely benzoic acid. But what do I want to know? I want to know, what if we change this up to be CH2COOH? What is that called? Wait, benzo. Wait, did I do an extra one? I don't know. We can go on forever. Let's just keep reading the book. I'm tired of this. Let's see. Okay, here. I'm gonna go put my pants on. It's getting cold now that I'm not in the sun. Identify the functional groups in the following model of aerocholine. Convert into line bond structure and molecular formula. Let's just do the functional group thing. That's an amine. This, I don't know if you consider that an arene. This is a, it's not a carbolic acid. This is an ester. Ester and amine. And this is the, just the normal alkene. Or what do you call it? I don't know. I think you call it just alkene. All right. Alkanes and alkane isomers. Before beginning a systematic study of the different functional groups, let's look first at the simplest family of molecules to develop some general ideas that apply to all families. We saw in section 1.7 that the carbon-carbon single bond in ethane results from sigma overlap of sp3 hybrid orbitals. If we imagine joining 3, 4, 5, or even more carbon atoms by CC single bonds, we can generate the large family of molecules known as alkanes. Alkanes are often described by saturated hydrocarbons. Hydrocarbons because they only contain carbon and hydrogen. Saturated because they have only CC and CH single bonds and thus contain the maximum possible number of hydrocarbons per carbon, or hydrogens per carbon. They have the general formula CnH2n plus 2, where n is an integer. Alkanes are occasionally called aliphatic. There's like a larger bird that's coasting, and then there's two crows, and they're above him, and they're trying to dive bomb and take him out or something, but like they keep missing. I feel like why are they missing so much? And the bigger bird is just coasting, trying to tire them out or something. It's gone. Think about the ways that carbon and hydrogen might combine to make alkanes. With one carbon and 4 hydrogens, this only one structure is possible, methane. All right, the isomer thing. We get the punchline. No, but here, let's look at some names. 2-methyl propane. Yeah, 2-methyl butane. 2,2. Why do you have to specify di? Shouldn't di be included in the count? Okay, isomer counts. Okay, I did this all yesterday. Let's just keep going. All right, so I did this on the board. That was easy. The only thing is that it's kind of tricky is it's actually easy to draw things that look like they're unique, but they're not, based on angles. Okay, all right, this seems fun. 2 isomeric esters with the formula C5 H10O2. All right, so first off, an ester is RCOO R prime. And then we need C5H10O2. Okay, that was actually pretty easy. Okay, 2 nitriles. C4H7N. So let's just start off with drawing the pattern. So nitriles are R triple bond N. Okay. So because we're going to get a butane, right? Then let's do this. So we're going to do C triple bond N. So then we're going to have H. So 3, 4, or 3, 5, 7. Okay. Now what we can do is we can do oh wait, you can't do that. But you can do that. So one's like the isobutane kinda, and one's like the straight chain. 'Disulfides, okay. C4H10S. Wait, S2. So let's first just do, C, S, S, C. Two, two, three, three. So we have 10. Okay, now we can just do this. So you can do CCCSSC or you can do CCSSCC. All right, that's. Ooh, this actually seems pretty fun. How many isomers? Alcohols of formula C3H8O. Okay, so wait. H8? C3H8? Oh yeah, because there's one here. Yeah. I think there's only one. I think there should be two. Thioesters. C4H8OS. So, first off, thioester is like an ester. Wait, oh yeah. So we're going to have a C, we're going to have a C double bond O, single bond S, and then this needs to be a C, and this needs to be a C. So we have 3 accounted for. So I think that there's 2 options. So we're going to have 3, 2, 3. Wait, what? H8? I'm forgetting something. Oh, no, that's right. Yeah. Maybe there's 2 of them. I don't know. It depends if you allow. Let me go back to the. No, you need to have a carbon there, but. Oh, that's so That's so confusing. So in a sulfide or a thioether, oh, oh. All right. I'll be back in a minute. I gotta go do some dishes and then make some food. All right, so the sec trans thing makes sense. This sec butyl because um there's secondary bonding. The terms primary, secondary, tertiary, and quaternary are routinely used in OCHEM, and their meanings need to become second nature. For example, if we were to say citric acid is a tertiary alcohol, we would mean that it has an alcohol functional group bonded to a carbon that is itself bonded to three other carbons. So methanol is not a tertiary alcohol. Okay, that makes sense. That's cool. In addition to speaking of carbon atoms as being primary, secondary, or tertiary, we speak of hydrogens in the same way. Primary hydrogen atoms are attached to primary carbons. Secondary hydrogens are attached to secondary carbons. And tertiary hydrogens are attached to tertiary carbons. There is no thing as a quaternary hydrogen because, yeah, that makes sense. So primary hydrogens, secondary hydrogens, tertiary hydrogen. Okay, that makes sense. All right, let's do it. 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 All right, so we're drawing the 8. Oh, really? Oh, man. Okay, pentyl isomers. Oh, this is actually not easy. Draw the 8 5-carbon alkyl groups. Okay, so I would say first we have 2, 3, 4, 5. That's one of them. So this is question 3, 7. And then we have with it on the end, or let's say, Oh wait, I think they have answers. So wait, hold on. Let me check off the ones that I have. This one, this one, and this one. Those are the easy ones. I think it's this one. This one, CCC dot. CCC dot. And then here we have CCC branch. CCC branch. And then, okay, so then this one. Then we have C branch. CC. Okay, then we have this one. Then this one is this, where you have oh wait, actually, yeah, CCC branch. Okay. Oh wait, yeah, CCC branch dot. Then we should have uh oh, what is this? This one is, I think that's that one. Because you have this branch here at 2. You go one more, then there's the thing. What's this one? Let me draw it how they have it. So we have these first 3 make perfect sense. Then you have CCCC branch break. Okay. Then you have CC branch CC break. And that one, it would be equivalent to Okay, so we have the fifth one now. Now the sixth one is C C C C C, like this. Um, okay, wait, so I did 6, which was this one. This one's interesting. We have C C C C C C. Oh yeah, the last one's really interesting. The last one is really interesting because of the quaternary. All right, let's go back. Okay, primary, tertiary, secondary, primary. Let's see, do they have the answer to everything? Dude, I love that these OpenStax textbooks, they have the answer to everything. Is it primary, secondary, tertiary. Okay, good. Okay, let's just write it down to my, so now 3, 8, B. Right, so we have C, P, oh yeah, T, PSTSP. Okay, good. C, PQST. All right, that problem was really easy. An alkane with 2 tertiary carbons. Okay, what's the second part? An alkane that contains an isopropyl group. What the hell is isopropyl? Did they explain the iso? So I guess you just need to know that isopropyl specifically means the middle. Isopropyl equals propan 2-ill. Okay. All right, alkanes. Let's get back to it. Okay, so then alkane that contains an isopropyl group. We'll draw C, 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 H, 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 H. So I just drew isobutane. Oh, wait, let's do C first. Then we'll check our answers. An alkane with one quaternary. Okay, so Q equal to 1 and S equal to 1. Okay, that was pretty easy. Yep, that's exactly what I drew. This, yeah, that's fine. They just added a big bunch of extra stuff. I just drew isobutane. Let's just check. Isobutane, or let's just say 2 methylpropane, yeah. Wait, what? 2-methylpropane isobutane can be viewed as containing an isopropyl fragment, but it does not contain an isopropyl substituent group. What does that mean? Okay, that's nuanced. I'm going to continue. And then this is exactly what I drew. All right, good. Oh, here we go. Naming alkanes. In earlier times, when relatively few pure organic chemicals were known, new compounds were named at the whim of their discoverer. Thus, urea is a crystalline substance isolated from urine. morphine, acetum. As the science of organic chemistry slowly grew in the 19th century, so too did the number of known compounds and the need for a systematic method for naming them. The system of nomenclature we'll use in this book is that devised by the IUPAC. A chemical name typically has 4 parts in the IUPAC system: parent, prefix, locant. Oh, wait, hold on. Parent, prefix, locant, suffix. Okay, prefixes. Damn it. Yeah?